Here we can show this simple neuron with some inputs, with set of inputs, which we can just represent it with a vector of x, and then each neuron has its own weight, a specific weight. We can just show them with a vector of w, and there is also a constant variable b, which we call it bias of our system. And then finally this one will give us some output. We have also some function which we call it a function of net. Here we have a function of net which equals w1 x1, because our inputs is just a vector of inputs, so there can be several inputs based on our data. w1 x1 plus w2 x2 plus, let's say, w of n xn. And of course we have a constant number b. Now we can show it with metric. We can say that these are w1, w2 to w of n, and then here we have another matrix which is x1, x2 up to x of n plus our b. Meaning here we have a horizontal matrix multiplied by a vertical matrix, and in a matrix we know that this one would be x1 times w1, w2 times x2, and finally wn times x of n. And here we already know that our x is a vector of x. We can just show it with x1, x1, x2 up to here x of n. The same with our weights, our w, which shows how effective is some input and what is the effect of each input on our output. w1, w2 to w of n. We can already write it down as a w transpose, because we have here the transpose. This one is horizontal, but our matrix is vertical. So w transpose x plus b. And our output, which is z here, now we can write it as z equals f of net. And here this net signal would be f of w transpose x plus b. We just showed our output of this neuron by using a function of w transform, which is our weight vector, and x, which is our input, and finally plus a constant number. With a simple mathematical function we can represent our neuron. Let's take a look at this AND gate and see how can we just show that with a new formula that we just found out. Here we have AND. This is based on y-axis and x-axis. These are our inputs, and these circles are representing 0 for output, or let's say totally false, and this triangle is showing 1 for output, or totally wrong. And we already learned that we can separate them with a simple line. This is the equation for this line, and each line is representing one neuron. Let's take a look at this equation one more time. Z can have two output. Z is equal to here x and y, and it can have two output. This is either 1 or 0. This is 1 whenever x plus y minus 1.5 greater or equal than 0. Here, this part. These are our 1, and for this one the z can have output of 0 whenever x plus y minus 1.5 is less than 0. But by looking at this function and by looking at this equation, what can you remember? I think this is pretty clear. This is our step function, or f of t, which has two output, 1 or 0. Whenever t is greater or equal than 0, this is 1, and whenever t is less than 0, that's 0. So meaning we can write it already z equal to f of t, and here our t is the net function. So we can also write it as f of x plus y minus 1.5. So meaning in a mathematical view we can simply show a neuron with this function.